Good morning, everyone. Here I'll show you some courses about the infinite series. We'll show you the first definition about the infinite series is the sum of consecutive real numbers respecting some organized way. So we have here the sum of real numbers. So the infinite series it's relates to two distinct sequences. So the first one is the partial sums. The study of the behavior of the infinite series it relates to the study of the partial sums. So if the limits of the partial sums exist, so it exists some finite value of the sum. So the sum of the infinite series exists. So after that, I will show you the first example about the infinite series called the telescopic series. The telescopic series is the sum of the consecutive real numbers. Here we will show. I will illustrate some kind of telescopic series. The first technique of the first skills to do it in order to the study of the convergence of the series is to split the partial fraction into two expressions. So throughout the composition of the partial fraction. After that, we will rearrange the sums into two terms until we find some expression that which limit of the partial sums goes to 1 as n goes to infinity. After that, I will show you. I will tell about the Riemann theorem about the infinite series written in the given expression. As first, the infinite series converge when the power alpha is greater strictly than 1. I will show the basic convergence test of the positive series. So the positive series means that every terms of the series is positive, is respecting some condition. We can show study the convergence of the series. We will begin with the comparison test. We will study some series greater than the origin series. So the inequality leads to some interesting results. So the comparison test said that if u sub n inferior than v sub n, so if the v sub n converges, which applies that u sub n converges. Here an example illustrate the example about the use of the comparison test. So 1 over n squared plus 1 is it's no greater than 1 over n power 2. So respecting the Riemann theorem, here alpha equal to 2. So we conclude that throughout the comparison test that the infinite series converge. The second test is called the Cauchy test theorem. The Cauchy test consists that the study of the series is this kind of the series. So the study of the sequences u sub n power n over 1 n goes to the infinity. The condition of the convergence of this kind of series is the limit it's not equal to 1. Here some example, an example illustrates some kind of the series that have the expression. By applying the root test, we obtain the result. Now we will show the general series. It means that the series have two different signals. It means that positive signal and negative sign. Here, essentially, the concept of we will see the concept of the absolute convergence. It's related to that if the infinity series converge if and only if the absolute value of the terms converge, which means that the infinite series converge. Here we will show that the alternating series. The alternating series is expressed in the following expression. It may begin with the first term, its negative or the positive terms. So we will show that the alternative series test, called the Leibniz theorem. The study of this kind of series is related to the study of the sequences U sub n. So we have two conditions. So if U sub n is decreased sequences, and the limit of the U sub n sequences go to 0, 1, and go to the infinity, that we deduce that the alternative series converge to some sums. Here an example about some alternative series does not converge because it's not verified the first conditions. It's finished. Thank you very much.